I welcome you all for the lecture on the topic properties of pure substance. Before getting into the topic, let us make it clear what is meant by pure substance. A substance which has fixed chemical composition throughout its entire mass is called as a pure substance. For example, water is a pure substance, as the chemical composition of water is H2O. Hydrogen is a pure substance, as the chemical composition is H2. It doesn't mean that a pure substance has to be of a single chemical element or a compound. A mixture of chemical elements or compounds is still claimed as a pure substance unless and until the mixture is homogeneous in nature. For example, air is claimed as a pure substance. Air is a mixture of several gases. You know that air is a homogeneous mixture, and hence mixture of components or chemical element is still claimed as a pure substance unless and until the mixture is homogeneous in nature. A pure substance doesn't need to be of a single phase. A mixture of two or more phases is claimed as a pure substance. Better example is that a mixture of ice along with water, ice in a solid phase and water in a liquid phase. The mixture of two or more phases is claimed as a pure substance unless and until the mixture is homogeneous in nature. Whereas if you take oil along with water, it is not a pure substance. As oil is insoluble in water, it forms a two distinct chemically invariable regions. It is not a homogeneous mixture, so we will neglect oil along with water as not a pure substance. I want to explain the properties of a pure substance with the help of a phase change process of a pure substance, otherwise called as formation of a steam. Now I am going to explain phase change process of a pure substance with the help of an experimental arrangement. In this arrangement, you are going to have a ice which is placed inside a apparatus, and you are going to constantly supply heat. For example, the ice which is at minus 20 degrees Celsius is going to be heated. In order to understand about the phase change process that is happening inside the chamber, I am going to have a graphical representation through which I am going to explain what are the phases the ice is going to change while heating. In order to explain that, in the graphical representation, heat added is going to be taken in x-axis and that of temperature is going to be taken in y-axis. Between process 1 to 2, that is, ice which is at minus 20 degrees Celsius is going to be heated at atmospheric temperature or atmospheric pressure. If you are going to heat the ice at atmospheric pressure, automatically the temperature is going to rise from minus 20 degrees Celsius to 0 degrees Celsius, which will be drawn as an inclined line in the graphical form. That is, from point number 1 to point number 2, that is from minus 20 degrees Celsius, the ice is going to be constantly absorbing the heat and the temperature is going to be rising to 0 degrees Celsius. If you are going to further increase the temperature from 0 degrees Celsius, the heat is going to be added, but the temperature rise is not recorded. And the amount of heat transfer that is happening during the phase, that is from point number 1 to point number 2, is called as latent heat of fusion of ice. Latent heat of fusion of ice is nothing but amount of heat transfer required to cause the phase change from solid phase to liquid phase is called as your latent heat of fusion of ice, and that is going to happen in the region 2 to 3. Once the entire amount of ice has been melted into liquid water, and again if you are going to further heat from point number 3, the temperature is going to rise from 0 degrees Celsius to 100 degrees Celsius. Why I am saying as 100 degrees Celsius is that 100 degrees Celsius is going to be the boiling point of the water. The temperature at which the pure substance starts boiling is called as your saturation temperature. Beyond the point number 4, if you are going to further heat it, means automatically the temperature is going to be maintained as a constant, since the phase change is going to happen there from liquid phase to that of your gaseous phase. So beyond point number 4 to point number 5, if you are going to constantly supply the amount of heat where phase change happens from liquid phase to gaseous phase, the amount of water particles suspended in the steam is going to vary from point number 4 to point number 5. Point number 5 is the region where there is no water particles suspended, which means that the steam is completely dry. In between point number 4 to 5, if you are going to tap a single point, that point is called as X. If you are going to take the point X and if you are going to study the quality of the steam, it is called as dryness factor. Point number 5 is steam which is a completely dry state, which means that no water particles is suspended under steam. If you are going to further heat that steam, the steam is called as superheated steam, which has been represented in the graph in the inclined form. Dear students, In today's session, we have seen in detail about properties of pure substance, and we have learned about what is pure substance and what are the phase change process that is happening in the pure substance, and we have seen it with the help of a graphical representation, and we have understood what is meant by dryness fraction, how dryness fraction plays an important role in determining the quality of the steam. Thank you.